Right, so let's have a look at another partial fraction expansion, or what's sometimes called a partial fraction decomposition. So this time what we're going to do is just have a look at this one here. It's 8x squared minus 12 divided by x times x squared plus 2x minus 6. Okay, so normally what we would do here is look at our denominator and see if we can factorize it any further. It's factorized into, if you like, x times this thing here, but this quadratic here is not factorizable any further, so we can't do any more with the denominator. So normally what we would do is this: we would divide it up into a over x, a little bit too big there, but a over x, and then we would say b over the other factor, which is x squared plus 2x minus 6. Now the problem with this is when you look at, let's say, this term here first, you have an x to the power of 1 on the bottom and you have an x to the power of 0 on the top here, so that's fine. The power of x on the top is 1 less than the power of x on the bottom, so we've accounted for all possibilities here. Now here we have an x to the power of 2 on the bottom and we have an x to the power of 0 on the top, but there is a possibility that this numerator here could have an x to the power of 1. It could have a degree of 1, in other words. So in other words, it could look like this: bx plus c. Now what we could find is that b will be 0 anyway, so there'll be no x value on the top, so there'll just be a number. But we have to allow for the fact that the numerator here could have a degree of 1. The x value here could have a power of 1 on the top, so we have to allow for that. So in other words, the degree of the numerator is 1 less than the degree of the denominator here. So once we have that sorted, all we got to do is do what we normally do: add these two fractions. So what we get here is x times x squared plus 2x minus 6 as our common denominator. Divide x into our common denominator, you get this here, multiply it by a, so that gives us a times x squared plus 2x minus 6. Divide this x squared plus 2x minus 6 into our common denominator, gives us x. Multiply that by our numerator here, that gives us x times bx plus c. Okay, so that's our two fractions added. Now what we want is for this fraction here to be equal to this fraction here. Now we can see our denominators are equal, so that's fine. So really what we want is our numerator here to be equal to this numerator up here. So we got to work out what a, b and c are. So in other words, what I want is for 8x squared minus 12 to be equal to a times x squared plus 2x minus 6 plus x times bx plus c. So this is what these two I need to be equal to each other. So now what I've got to do is work out what a, b and c are. So let's do that. Well, here we have 8x squared minus 12. On the right hand side we've got ax squared plus 2ax minus 6a plus bx squared plus cx. Let's just tidy this up a little bit. So I'm going to take this x squared here and this x squared here. I'm going to put them together and factorize. So I end up with this a plus a b here. They're both multiplied by x squared. Now I'm going to take this x here and this x here. I'm going to put them together, factorize them, so that gives me a 2a, and I have a plus c. They're both multiplied by x. Now what I also end up with here is, let's see, I have this minus 6a here as well, so I'm going to put that in here at the end, minus 6a. Okay, so now I have something x squared, something x, and a something without an x, and on this side I have the same thing. I have an 8x squared, I have a 0x in here which I haven't written in, and I have this number independent of x here as well. So what I can write down here is that a plus b here must be equal to 8. This here must be equal to this 8 here. That's what I want anyway. This 2a plus c must be equal to 0 because I have a 0x in here which I haven't written in. And then this minus 6a here must be equal to this minus 12. That's what I want. I want this minus 6a to be equal to that minus 12. So immediately then I can see here that over here I can just divide across by minus 6. So that gives me a is equal to 2. If a is equal to 2 here, I can just come across here and I can put 2 in here. So in other words, I get 2 times 2 plus c equal to 0. That gives me 4 plus c is equal to 0. That gives me c is equal to minus 4. Now I have a and I have c. All I've got to do now is just work out what b is. So I can see here, if I have a here, I can say a is 2, so I've got 2 plus b is equal to 8. So that gives me then b is equal to 6. So now I have b, I have c is equal to minus 4 here, and I have a is equal to 2. Okay, so now all I've got to do is just rewrite my original fraction here. This was my original fraction. I split it up into two fractions here with a, b, and c in my numerators. So I just got to put a in here, b in here, c in here, and that should work. So let's just put those in then. So my original fraction was 8x squared minus 12 over x times x squared plus 2x minus 6. I decided that was equal to a over x. Well, a is 2, so that's 2 over x, plus I had a bx plus c, so that gives me 6x plus c, which is minus 4, and that was over the x squared plus 2x minus 6. So this here is my final answer. So if I add these two fractions together, I should end up with this here. Let's just check that out and see does it work. So I'm just going to test this to see does it work. Let's add these two fractions. Well, my numerator I know, or my denominator rather, I know that will work. That's x times x squared plus 2x minus 6. If I divide this in here, I'll get my quadratic expression here, multiply that by 2, so that gives me 2 times x squared plus 2x minus 6, plus divide this quadratic into this common denominator here, that'll give me x, so that'll give me x times 6x minus 4 on the top here. Okay, so next line then, let's just multiply this out. I get 2x squared plus 4x, 2x squared plus 4x minus 12 plus 6x squared, here this is 6x squared, plus, no sorry, plus times minus is minus, so that's minus 4x. On the bottom here I end up with the x times x squared plus 2x minus 6. So on the top here, let's see, I've got a 2x squared and I've got a plus 6x squared, so I'll just write that over here. So that gives me 2x squared plus 6x squared, that gives me 8x squared. I've got a plus 4x minus 4x, so that's just going to give me 0. And I have the minus 12 here. 6x squared and the 2x I've already added, so that's fine. On the bottom I've got the x times x squared plus 2x minus 6, and that is the same as this here, so it does work. So this here was my final answer here.